Hello boys and girls, and welcome to lesson 1 from chapter 6, Powers and Exponents. This lesson is found on page 433. A product of like factors. When we say like factors, means factors, numbers that you multiply that are the same. These are like factors. You see, 10 and 10, they're factors and they are like, they're the same number. They can be written in exponential form using an exponent and a base. The base is the number used as a factor. This is your base. The exponent tells how many times a base is used as a factor. This is your exponent. So how many times am I going to multiply this into itself? 2 times. See, 1, 2. Fill in the boxes with the words factors, exponents, and base. Well, the numbers you multiply into themselves, whenever you multiply a number, we call those factors. Okay? When we write it in exponential notation, the number is called the base. And the little number that tells us how many times we multiply the factors into each other is called the exponent. Give an example of an exponent. Well, the 2 in the exponential notation 4 to the power of 2, or 4 squared, is an exponent. So this 2 is an exponent. Please copy this example down as a key answer. Write the definition of exponent in your own words. Now, if you think you can do this, go ahead. Write it in your own words. But I would say in a power, the number that tells how many times the base is used as a factor. That's what it is. This tells you how many times this power, this number, is used as a factor. In a power, the number that tells how many times the base is used as a factor. Okay, now let's look at the real world connection. MP3 players, this is music player, right? Like an iPod. MP3 players come in different storage sizes. You know, you can get a gig and so on, 5 gigs. Some of them are 64 gigs, such as a 2 gig, 4 gig, 16 gig, where gig or gigabyte means gigabyte. 1 gigabyte is equal to 10 times 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 10 bytes. Wow. What is the number written in exponential with exponents in exponential notation? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10, right? 10 to the power of, how many times does it repeat? 9. So go ahead and copy that down. Next page. Write productions of powers. Numbers expressed using exponents are called powers. For example, 100 is a power of 10 because 10 times 10 is 100, right? Because it can be written as 10 squared or 10 to the power of 2. Numbers like 100 are called perfect squares. Other perfect squares could be, for example, like 16, because you know that if you multiply 4 times 4, right, you get 16. Another perfect square could be 25, which would be 5 times 5, right? Those are called perfect squares because they are the squares of whole numbers. 4 times 4, 16, 5 times 5, 25. Here we had these in 5th grade where you just have one flat layer and we have 10 by 10, so that means we have 100 little squares. Okay, 10 squared. You can also have the 10 by 10 and then another one by 10 in depth. So this one will be 3 dimensions, so we have 10 by 10. Here is 100, but then when you add the other layer, it will give you 1,000. So there's 1,000 little squares there, 10 to the power of 3. Perfect cubes are numbers with 3 identical whole numbers, factors such as 4 times 4 times 4, which is 64. So the number 64 is a perfect cube. Perfect square means to the power of 2. Perfect cube means to the power of 3. 1, 2, 3. Okay. You can see here that 6 to the power of 4, right? 1, 2, 3, 4, so 6 to the power of 4. Write 4 to the 4 times 4 times 4 using exponent. The factor is 4, right? That's the number we're multiplying into itself. The factor is multiplied how many times? We're going to multiply it 1, 2, 3. Therefore, the exponent is what? Well, 4 to the power of 3, right? So 4 times 4 times 4 can be written as 4 to the power of 3. Okay, let's practice here. 7 times 7 times 7 times 7. Our base is 7. That's our factor. How many times does it repeat itself? 4 times. So 7 to the power of 4. And now 9. 9 is our factor, that is, it will be our base for our exponential notation. So 9, we write it there. How many times does it repeat itself? 1, 2, 3, 4, 5, 6, 7. So it's 9 to the power of 7. Okay, this is something we need to make note of. To write powers as products, okay, as products meaning when we multiply them with each other, right? So let's say I have 10 to the power of 2 times 10 to the power of 2. Let's see. Determine the base and the exponent. The base of 10 to the power of 2 is 10, and the exponent is 2, right? 10 to the power of 2. To read powers, consider the exponent. The power 10 to the power of 2 is read as 10 squared, and 10 to the power of 3 is read as 10 cubed. So we can say 10 squared and 10 cubed. Okay, for examples 3, we're actually going to solve. We have 5 to the power of 2, which means 2, 5, and then we write it in standard notation. You see that? And then we have 1.5 cubed to the power of 3. We write it, and then we write it in expanded notation, right? Where we actually write out all the factors, and we solve for it in standard notation. And we can write it the same thing with a fraction, half. Half is being multiplied into itself 3 times. You can see it here. Half times a half times a half. When you multiply, a half of a half is a fourth. And then a half of a fourth is 1/8. And there you go. Write each power as a product of the same factor. Then find the value. Okay, 10 to the power of 5. Please write this down. It looks like this. 10 times 10 times 10 times 10 times 10. 10 to the power of 5. Okay, what is that? Well, here's a little trick, everyone. If I multiply 10 times 10, I'm going to have the 1 plus the 2 zeros. If I multiply 10 times 10 times 10, I keep my 1 and then I add the 0 in, which would be 1,000, right? And if I add all of the 0, if I keep that pattern going, I will have my 1 from right here, right, from the first one. And how many zeros? 1, 2, 3, 4, 5. So I would have 1, 2, 3, 4, 5. Therefore, my standard notation is 100,000. Let's try that with 2.1. So we have 2.1 times 2.1 because it's squared. It's 2 of them. Okay, what's 2.1 times 2.1? Let's multiply it. 1 times 1 is 1, 1 times 2 is 2, 2 times 1 is 1, 2 times 2 is 2, sorry, and 2 times 2 is 4, right? And then we add it. We have 1, 4, 4 when we add it. Where does my decimal go? Right there? Oops, I didn't need that bottom line. It goes 1, 2, so I count 1, 2, and I get 4.1. So 4.41 is my answer. And finally, the same goes for this question. What a fourth times a fourth? Well, what is a fourth of a fourth? Remember, when we multiply fractions, we just multiply directly across. So I would have 1 times 1 equals 1, and 4 times 4 equals 16. So my answer would be 1/16. And finally, for example 6, we have a word problem. Michigan has more than 10 to the 4th power island lakes. Wow, inland lakes. So it has a lot of lakes, 10 to the 4th power. Find the value of 10 to the 4th power. Well, 10 to the 4th power is written as so. So we write it 4 times, and remember the trick where we just count, we take the 1 and we write our 1 down, and then we count the number of zeros. 1, 2, 3, 4. And I have 1, 2, 3, 4. So it's the land of 10,000 lakes. There it is. Michigan is the land of 10,000 lakes. Okay, please leave the guided practice for class so we can do it as a warm-up, but complete the independent practice on your own, including the back of the page. Don't forget to do this as well. Remember, you can solve for this and then add your 1. Turn this into a standard notation and then add the 1. Turn this into a standard notation and then multiply it by 10. Okay, see you in class.